Now, having said all that, what we're going to focus on today is accelerated database recovery. And this was a feature that was introduced with SQL Server in the box product with SQL Server 2019. It's actually been in Azure for a little bit longer than that. You might have also heard this referred to as the S-log. Sometimes I hear certain aspects of it referred to as constant time recovery. No matter which name you use to refer to it, it all works off of a certain set of features and capabilities that have been wrapped up in the SQL Server. So what we're going to talk about today is a little bit about an overview of what ADR is, how to manage it, some of the things that you might want to consider if you're going to implement accelerated database recovery, or I'll try to remember to call it ADR so we don't take up too much time in the presentation. I think it actually adds a good 3 or 4 minutes if I keep saying accelerated database recovery. We're going to spend most of our time in demonstrations. I'm going to go through the slides fairly quickly, and then we're going to jump over into Azure Data Studio, and I will show you some code. We'll run some scripts, and we'll see what happens. And then we'll leave as much or as little time as we need at the end for Q&A and go from there. So again, accelerated database recovery introduced with SQL Server 2019. Really, this was built to address a very key set of issues, which is around rollback and recovery of transactions. So what we wanted to provide with this feature is a consistently fast recovery, no matter how long you've been running a transaction, or no matter how big your transaction log was at the time that either your database crashed or you restarted SQL Server. We wanted to speed up that process because that was a huge pain point for a lot of people when it came to database recovery times. Now you notice on here under capabilities it says instant transaction rollback. I'm not kidding. I'm not kidding. You will see in a couple of the demos that we do later on that transaction rollback time actually comes up as zero milliseconds. It is honestly quite that fast. Another feature that came into it, or another capability of accelerated database recovery, is this idea of aggressive log truncation. Not as much information needs to be written into SQL Server's transaction log when you're using ADR, because some of that also goes into another part of the system, which is called the S-log, and then some other information that's needed to rollback transaction goes into a completely different place. So we'll go through all of those pieces and parts as we go on describing what this feature is and what it does. Okay. So current state of transaction logs, this is what we all know, and either, I guess we sort of have a love-hate relationship with the transaction log in situations like this. But the current thing we're using is called the ARIES model, which is Algorithm for Recovery and Isolation Exploiting Semantics, which is just a bunch of fancy words to say, read the instructions that you have in the transaction log and do what I told you to do. Okay, SQL, this is what I told you to do, just go ahead and do it. Now, I have to do this in 3 phases. The first is the analysis phase, then we go through a redo phase and an undo phase. If you've ever read anything about database recovery, well, like we're during database startup, the different phases that it goes through, and sometimes if you open up your SQL Server error log, you'll see lines in there that say something like phase 2 recovery lasting for another 300 some odd seconds or whatever it is. So those 3 phases that we have to go through when we read a transaction log for recovery purposes: analysis, redo, and undo. This is going to happen anytime you start up a database, whether you restarted SQL Server and it's coming back up, or whether you take a database offline and then bring it back online. It has to go through these 3 phases of recovery. The biggest issue that we have with this is the amount of time it actually takes for you to recover is directly proportional to the amount of work that has to be redone. So the more uncommitted or unbacked up transactions that you have in your transaction log, the longer it's going to take for you to bring that database back online. Let's actually go ahead and skip forward to this slide here so we can actually talk through a little bit of what these phases look like. So in the analysis phase, SQL Server does a forward scan of the transaction log from the last successful checkpoint, or what would be the oldest dirty page log sequence number, the oldest record that affects a dirty page in the transaction log. scans that whole thing forward, just basically to try and estimate what was the state every transaction was in at the time SQL Server, was stopped, or at the time that that database was taken offline. Phase 2, which you normally don't see phase 1 in your transaction logs, or not in your transaction logs, but if you look in the error logs and look at the different phases that your database goes through during recovery, normally you won't see phase 1 because phase 1 is generally pretty quick. And that analysis usually happens very, very quickly. If you had a lot of open transactions, you may see it in there for several seconds, or if you're having IO issues reading your transaction log, that's another time where you might actually see a longer phase 1. But generally, phase 1's pretty fast. The two that take a really, really long time are redo and undo, so phase 2 and phase 3. For the redo phase, SQL Server, again, scans that transaction log forward, but it goes to the oldest uncommitted transaction. So this could be a lot more transaction log than what you have in the analysis phase. So starts at that oldest uncommitted transaction, reads it all the way to the end, and looks for transactions that have been committed, but where that page has not been updated in the database. It makes that update, and it makes sure that your database is in the state that it's supposed to be in once it gets to the end of the transaction log. And then finally, we go through the undo phase. Okay, so for every transaction that was active but had not committed at the time that the database was shut down, crashed, SQL Server stopped, whatever happened, it reads the transaction log backwards from the end of the log all the way back to the oldest uncommitted transaction. Anything that had not been committed, anything that was either aborted or had not had a completion record logged in the transaction log, that work gets undone. So this whole process, reading it forward again, reading it backwards, that's just to make sure that whatever it says at the end of the transaction log, this is the state my database is supposed to be in, that's where we want to be. And like I said, that could be a lot of work, depending on how much was going on inside, how much transaction volume you were having in your database at the time that SQL Server or your database stopped. Right. So what's the new stuff? Well, the new stuff is ADR, or Accelerated Database Recovery, and that has a few different components to it. The first is this persisted version store. And the idea of this is, I remember having these kinds of discussions with people who were a little worried about using read committed snapshot isolation, or using snapshot isolation where we have versions of records in our database. The persistent version store works, or persisted version store works a lot like that, in the fact that when you make a change to a record, a copy of that record gets put in the persisted version store, and then SQL is just saying, okay, which version of this record is current? Which version of this record should I return to this transaction that's running right now? So it can read it out of the base table, it can read it right out of the existing data file, or it can read it out of this persistent version store. The persisted version store, or PVS, it's another 3-letter acronym I'm going to try and remember to use. But the PVS actually resides in each database itself. So for read committed snapshot or snapshot isolation, that version store resides in tempDB, so you could really blow out tempDB. In this case, we're keeping that version store inside the database itself, which, and I'll show you where that goes in the demo database that I have. So all of those different versions for rows that are being updated, deleted, all of those are being stored in that within the database itself in that PVS. A logical revert is basically an undo, like a Control-Z for a transaction. So you create a record, you go to update it or delete it. That record, copy of that record gets moved to the persisted version store. And when you do your, when you say, oh, you know what, I don't want that record, I don't want that update, I'm going to go ahead and roll that transaction back, nothing changes. Nothing has to get changed on disk. It just says, hey, next time somebody wants to query for that record, it's over here in the persisted version store. You don't have to go and read the one that's in your primary data file or your secondary data file. You read the one that's in the persisted version store. That's what we mean by instant rollback. So when I roll back that transaction, SQL Server just marks that row that's stored in your main data file as invalid. So yeah, it's still sitting here, but that's not the row you want. The one that you want is the one that's in the persistent version store. So the next part of this is the slog. And slog is a secondary log. It resides in memory, so it's not taking up space on disk, and it's incredibly fast. It's also low volume, so not a whole lot of information gets put into the slog. What it's for is it's for non-version log operations like lock acquisitions. Some DDL statements or DCL statements will go to the slog instead of going to the transaction log. And by maintaining only the non-versioned operations, it makes redo and undo much quicker because SQL Server doesn't have to make any data changes for a non-versioned operation. Like if I'm making a change to just like a metadata change on a table, that doesn't actually affect the data that's in the table, that change can go to the slog instead of the regular transaction log. It can also make that transaction log truncation not a lot quicker because only the records that are required for like versions changes, those are the only ones that are going to the transaction log in the first place. And then finally, we have this thing called a cleaner. So there is a stored procedure, and I'm surprised I don't have the name of it here in my slides, but you know what, I'll add that. I'll add that before I distribute these. But there's a stored procedure that runs periodically that goes through and it cleans up records that are no longer needed in the persistent version stores. Once changes have been committed, then we don't need to have that information in the persistent version store anymore. And I can go back and clean those up. So earlier when we were talking about the Aries model, we were talking about the 3 different phases of recovery. They're a little bit different when we get into accelerated database recovery. So the analysis phase is pretty much exactly the same as it was. So you're scanning forward from the last checkpoint in the log. Actually, let me go ahead and move to this slide instead. All right. So we're scanning forward in our analysis phase from the last checkpoint, exactly the same as we did in the previous model, in the Aries model. Again, this is usually pretty quick, so we're not too concerned with optimizing this one. But the next thing is that redo phase, number 2. This is 2 and 3 is usually what takes up the most of the time, and usually it's 2 doing all of those redos. So this gets broken out into 2 subphases. First, we redo things from the slog. So whatever the oldest uncommitted transaction that would need to be redone from that slog they're updated or replayed from the slog. And usually there's only a couple of these. Again, this is for non-versioned changes, things that don't actually affect the row version, things that don't actually affect the data as it's sitting in the database. Those can generally be done pretty darn quick because it's only going to be a few records. And then the second half of phase 2 is that redo from the transaction log. Now, at this point, we're only reading from the last checkpoint because anything before that checkpoint is going to be coming out of that slog. There's a limited amount of information retained on both sides because of that. And then in the undo phase, with accelerated database recovery or ADR, this is almost instantaneous because again, all of the changes from the oldest uncommitted transaction that would need to have been applied would have been applied from the slog. And then we're only going from the end of the log back to the last checkpoint rather than to the oldest uncommitted transaction. So again, really, really quick. Okay, now, sounds interesting. And I know when in some of these demos that I do, people's eyes kind of get wide and they say, wait a minute, what? How did that happen so fast? And we'll talk about that a little bit in the demos. But there is a why and a when to using ADR. Specific situations that it's going to help you with. Frequent long-running transactions. So you have a workload that runs, maybe you've got a data warehouse side, like an analytic workload that has frequent long-running updates, long-running deletes. That's the type of thing that you would want to use accelerated database recovery for. If you have anything that causes your transaction log to grow large amounts very, very quickly, Another good situation for use of accelerated database recovery to help manage that size a little bit more. Frequent long recovery. So if you've got long periods of downtime for your database due to recovery, so manual transaction rollback, unexpected restart for SQL Server. This can also apply, by the way, to failover in availability groups as well. Because remember that information is persisted between availability groups. The one caveat to using this with availability groups is, and actually I will go ahead and move forward to the next slide to talk about that a little bit. The one caveat to using this with availability groups is that ADR is off by default, and you have to have exclusive database access to turn it on. So turning ADR on or off means you have to have an exclusive lock on the database. No transactions can be processed within that database while you're changing the ADR state. So yeah, that's another one of those cases where you have to kick everybody out. If you're moving a database into an availability group, you want to turn accelerated database recovery on before you do that, or once you move it into the availability group, you need to make sure there's no workload on the secondary server before you turn ADR on or off. This is all managed by DDL, so there's some, I'll show you when we get to the demos. It's just a simple alter database statement. The persistent version store, you can specify a location for that when you turn accelerated database recovery. When you turn ADR on, you specify the location of the persistent version store. You can just leave it in primary. That's by default where it's going to go. And you can change the location of the file group where you want that persistent version store, but you have to have ADR turned off to do it. So you would turn ADR off, turn it back on, and specify a different file group for the PVS, and then you'll be able to move that. Some other quick caveats as far as managing ADR. You have to have enough space for your persistent version store. Depending on what type of workload you have, this is quite honestly something that you're just going to have to test in your environment. I know that, and we can show when we get to the demo scripts, that deletes take up very, very little space as far as the PVS is concerned. Updates take significantly more space in the PVS because we're storing a lot of row records in that PVS for that. There are a couple of DMVs that you can use for that, and I'll show you in the demos. There's this DMTran persistent version store stats. We'll make use of that quite frequently when we look at the demo scripts. And there's the cleanup store procedure. So the SP persistent version cleanup. You can run this manually. It will run by itself periodically to go back and clean up records in the PVS. Again, baselines are your friend when it comes to monitoring anything with SQL Server, and PVS size is no exception to that. You want to look for, when you're looking at this, when you're looking at that DMV, that persistent version store stats, it'll show you what's the oldest transaction that it has in there. You want to look, especially within availability groups, there's a column in there specifically called secondary low watermark. What you want to do with that column is actually compare it on both sides of your availability group. So it's not something that you can just look at in isolation. You need to look at your secondary low watermark on your primary and on your secondaries as well, and see how far out of sync those are. Those are basically, they're not counters, they're not counting anything, it's just a number that's increasing by a specific interval on both the primary and the secondary server. And if they get out of sync, it gives you an idea that there's a delay in the redo between your primary and your secondary when you're in an availability group. And then you can also look through the SQL Server error log. If there's any reason that the version cleaner, that persistent version cleanup store procedure, is unable to run, you will get that. You will get a message for that in SQL's error log. Okay, I think I only got one more slide here before we move on to the demo, and we will briefly pause for questions after I get through this slide here. Again, you want to make sure that you have sufficient space for your persistent version store, something that you're going to want to baseline when you start running this in your test environment. Can't do it on Express Edition. Sorry, there's not a whole lot you can do on Express Edition. So, and I don't really know too many people that are using it now that Dev Edition is free. User databases only. We can't do this within system databases, unfortunately. There are other optimizations that have been built in for system databases on 2019 and in Azure, and there's actually more going to be coming relatively soon. So I'm not totally concerned about that. And again, it requires exclusive access to the database in order to turn this on or off. So kick everybody out, make your change, and then let everybody back in. Or make sure that this is enabled when you roll out the database and permit user access. And again, it is off by default when you create a new database in 2019. So you will need to make sure that you turn it on as part of your database creation scripts. All right, so I'm going to go ahead and start getting some demos ready. Are there any questions from anybody? You can unmute, you can raise your hand, however it is that you want to do it. Or you can just, shout at me over the air and hopefully I'll hear you from here.
Not seeing anything posted in chat yet, but yeah, if anybody has any questions, feel free to unmute and speak up.
All right. And I tend to go through things fairly quickly sometimes. So. Let me make sure I'm on the right script. Which one are you? Okay, that. All right. Can you read my screen okay? Is the font size all right?
Looks good from here.
Okay, cool. All right. So some of the code that I have in these demos is actually, I'm sort of copying off of Bob Ward's paper. He's got a site out here on GitHub where he has a bunch of SQL workshops, and not just related to accelerated database recovery, but a lot of other features in 2019 as well. And I believe there's some Azure workshops out there. And there's also some stuff by Buck Woody on big data, whatever it is that you want to study. They've probably got a workshop out there on it. So feel free to go check it out. All right. So for sake of time, I've already done some of this work ahead of time. I'm just going to make sure that no count is turned on because that's bitten me once or twice. All right, we're good. Okay, so the first thing that I do in this demo is I go ahead and I create my database. And one thing I want to point out about that is that I have created the transaction log already at 15 gigs. Even though that my database is only sized for 1 gig. So I'm not putting a whole lot of data in there, but I am creating a good bit of transaction log space. And the reason that I did that for this specific demo is because I didn't want transaction log auto grow to be part of any delay or timing or anything else that happens while we're running these demos. So we're taking auto grow for the transaction log out of the consideration at this point. Another thing that I did is I included this function that was written by another friend of mine, Lewis Garrett. And what this does is it converts a 3-part hexadecimal identifier into a 3-part decimal identifier. And you're saying, Dave, what the heck is that for? Was a useless piece of ephemera there. Well, part of these demo scripts utilize a function that reads, it's fndb log, which actually reads information out of the transaction log and presents it. When you get the results back from fndb log, it gives you the log sequence number, or the LSN, in a 3-part hexadecimal format. When you provide that LSN number to fndb log as a parameter, you have to do it as a 3-part decimal format because consistency, right? So I've gone ahead and I've included this in the demo scripts as well. So you'll get to play with this, but I've created that already in my database. I've taken my database backup. You can back it up to a file if you want to. You want to play with some stuff later. I just back it up to null because all I need to do is run a backup and make sure it's in the right recovery model, which is exactly what I'm going to do right now. And then we will see that ADR is off by default. Okay, so here's my demo ADR database. Accelerated database recovery is off. All right, so recommendation is that we put our persistent version store in its own file group. So when we do the alter database statement on our demo ADR database, I'm going to go ahead and specify that I want this to be in its own file group. So I've created my file group. I've just called it demo ADR file group PVS. And I'm going to start with 1 gig's worth of space and an auto growth of 1 gig. So let's go ahead and add that. There we go. Should be all success, good. And then we'll turn it on. So when we turn it on, it's just an alter database statement. We're setting accelerated database recovery on and then saying, here's where I want you to put your persistent version store. All right. So here's a query that I use to look at the status of the persistent version store. And again, this is running off this dynamic management view right here, this DM train persistent version store stats. And just for convenience's sake, I'm joining this back to sys.databases and file groups. By default, this will show you persistent version store information for all your databases, but I just want to get it for the current database that I'm in right now. All right, so we've just created our persistent version store. So of course, we're going to be seeing zeros across the board here. So we see that our ADR state is enabled. That's where my PVS is residing. No size right now. Oh, online indexing, another thing that makes use of the persistent version store. So if you're doing a lot of online index operations, persistent version store or PVS, ADR is another feature that you might want to consider to help speed those things up a little bit. And just for convenience's sake, I've included a couple other queries in this demo script. The first is it just shows you all of the error messages that are available in SQL for persistent version store. I started doing this a while ago because I noticed that I was actually learning things about how various features in SQL Server worked by looking up what possible error messages that could generate. So being able to do that actually taught me a lot about some of the features in SQL Server. So this is something that you can look through as well. And then I know Dan is a big fan of extended events. I am a huge fan of extended events myself. I've also included names and descriptions of all the extended events that you can use to track activity for the persistent version store. The one that you're probably going to end up using the most is this PVS trace event. That dumps out a lot of the activity that actually goes on behind the scenes with the PVS. It's sort of like network tracing within SQL as well. If you use that, I'm trying to remember what it is. Not SQLOS. There's another. I won't say there's another group, but that SNI trace that you can use for diagnosing network issues or diagnosing connectivity issues.
A few questions coming in. If you want to handle
cool.
those.
Yeah, let's see what we got here.
So we got one saying, other than ADR, what else is the PVS good for?
What else is the PVS good for?
You'd mentioned online index rebuilds.
Yeah, online index rebuilds is another thing that ADR was designed to assist with. So the PVS isn't really a separate feature. It's a part of accelerated database recovery. So it actually benefits any situation where you've got versioning going on, like with online indexing. I'm trying to think of it. It can help with concurrency. It can help with. It was designed initially for recovery and rollback. But anytime you've got high concurrency, a lot of DML going on, a lot of updates, deletes, inserts. It can help with those things as well.
Other question was, if there is a lot of rows in the PVS, until the cleanup runs, does the fragmentation cause performance impact?
Okay, so if there's a lot of rows in the PVS, does the fragmentation cause performance impact? Not that I have seen, but most of the demos that I have done so far have been centered around rollback and recovery. As far as fragmentation goes, that's a really good question, and something that I should actually probably add to my demos. So I'm glad that was asked.
And
make a note. You go ahead.
Oh, and another one is, does the instant file initialization also work for ADR growth?
Yes, because ADR is considered, or that persisted version store and being in its own file group. Yes, it would be helped by instant file initialization as well, because it's considered part of a data file. So yes, IFI does apply.
All right.
Yeah, so along those lines, if I may, real quick. So this may be the only reason people ever build partitions. I mean, I'm kidding, of course, but
Mhm.
so is there benefit from multiple NDF files across this file group? Or I mean, like the transaction log is sequential, right? So I mean,
Right.
the benefit is capacity. And so in this NDF file, and the weirdness that it is to me, is there parallel benefit, or is it still linear capacity? You know what I'm trying to say?
Yeah,
In
yeah, I
this.
know where you're going with that. And this is treated as a data file. So the only other part of ADR that acts more like a transaction log is that in-memory S log. But the version store itself is a data file. So you can, yes, you can get advantages of having multiple data files, parallelism. Another thing that you would want to look for, especially if you have a high level of concurrency in this case, when you're talking about monitoring performance for your persistent version store, is you want to look for allocation map contention as well. So contention on global allocation map, share global allocation map, PFS contention as well. If you're having a lot of weights for PFS pages, that's a really good case right there to go ahead and specify, you know, eight files, 16 files, however many files it needs for you to be able to alleviate that contention when it comes to that persistent version store. That's a good question.
Cool. Thanks, David.
We're caught up on questions at this point.
All right, cool. So that's our setup for ADR. Again, fairly simple. Let's take a look and see how it behaves when we run some transactions. So I'm going to go ahead and create a table here. This is my data table, and I've got an ID column, and I've got a text column that's 8,000 characters. And again, the only reason I did that is because now I'm only going to get one record per 8K page. I'm going to go ahead and insert about 200,000 rows into there. And this usually takes me about a little less than a minute. I thought I turned no count on. Oh well. We'll give it a moment or two here to go ahead. We'll go through, create all of those pages, and then we will see what happens if we do some things to that table.
You had no count on the other window.
Oh, all right. Well, once this query finishes running, which should only be like within the next 30 seconds or so, so I'll come back and make sure that's turned on. A reminder to myself here. I think I shut down every other resource consuming process on this laptop. Yeah, earlier I was loading about a what was that, a 9+ gig extended event session for a customer, and then trying to set up these demos in the background. Was not having it.
Very nice.
And nope, you get to wait. Okay. All right. Y'all aren't hearing my background music, are you?
Nope.
Okay, good. I had totally forgotten I had that running, and then the saxophone solo started, and I'm like, ah. Forgot to turn that off. I need to make, now that I'm doing more of these virtual sessions, I need to make a pre-flight checklist for, okay, remember, turn the background music off, turn the light behind me off, you know, make sure the clock's not running, so on and so forth. There's a lot there. All right, so 1 minute and 47 seconds. That's usually considerably quicker when I have no count turned on, which I should. There we go. All right. Just going to make sure that's persisted to disk, and I'm going to add a checkpoint to my transaction log. I'm going to go back to master and just double check, make sure that ADR is turned off. Good there. So now I want to look and see how much transaction log space do I have used currently. All right, so 435 megs worth of transaction log space, so just a little bit over 2%. I'm going to make a note of that so I can refer to it later. 435 megs and about 2-ish. Closer, well, you know what? I'll say 3%. We'll round up. Just for sake of argument. And then the next thing I'm going to do is I'm going to use this function to go ahead and get that the last LSN out of my transaction log. Because what I want to do in a minute is I want to see how much transaction log or what kinds of records I'm actually generating in that transaction log when I do this. I'm going to go ahead and open a explicit transaction. And I'm going to just delete all the 200,000 rows out of that table. So let's see about how long this takes. Again, this could be quick, it could be slow. We'll see what happens. Okay, so about 11 seconds to run the delete. And how much transaction log did I generate in that 11 seconds? Quite a bit. So for deleting 200,000 rows, I've generated 8.5 gigs worth of transaction log just to do that. What the heck all went in there? So I'm going to go ahead and paste in my LSN that I copied earlier. Right? So whenever I do a paste and it shows me the exact same number, I get worried. Well, that's going to give me a different number anyway. I'm going to trust it. And I'll wait until this is
All right.
transaction log is longer or larger now, so that might actually take a second.
Okay, while we're waiting on that, we have another question that came in. It says, the PVS seems similar to an Oracle undo segment table space. I know this session isn't about Oracle, but for you, can you relate how PVS is different or similar to the Oracle undo segment, if you know?
I cannot, because I know how to spell Oracle, and that's about it. So it's what was that term that was used again? Oracle, what?
Undo segment table space.
Undo segment table space. Undo segment table space. I have no idea what that is, but I will know by the end of this week.
All right.
And we will find out. So I appreciate asking. I like it when people ask me questions that I don't know the answer to, because then I get to go learn stuff, and that's fun. So, hey, we got our Maxwell send back, which doesn't matter anyway. Go ahead and run this and see what kind of results we get. All right, so a lot of stuff basically happened in the transaction log. And most of it, if I recall correctly, is going to be modifications to metadata pages. There's a lot that has to go on behind the scenes, because again, every single one of those records had its own page. So there's a lot of metadata getting updated behind the scenes as well. If you have smaller records, not a whole lot, and the table that you're affecting doesn't have a whole lot of data pages, this operation might actually be a bit quicker for you. But once this comes back, we'll be able to take a look at that. See, I did this earlier today, and a lot of these were coming back in 20 seconds, 30 seconds. And this afternoon, it's apparently going to run just a little bit longer.
I blame the gremlins.
Well, I blame a lot of things. I mean, I've had my afternoon coffee already, but my laptop apparently has not. There it is. Okay, so a lot of clustered index operations and system transactions is happening a lot. Okay, this modify header is going to happen a lot, because we're modifying the headers on a lot of those pages. And there's our delete rows right there. And there are multiple phases to a delete. So we're going to see, we got our commit, we got our inserts. So there's our actual delete rows, mark as ghost. So there's our 200,000 rows right there. But a lot of this other metadata and a lot of other information needed to be updated as well. And during that whole thing, that transaction is still open. So we get a 1 back from our select at tran count, and there's our transaction information right there running under 55. Current row count of that table should be 0 if we've done everything correctly, and it is. So now we're going to roll back that transaction. So that transaction took about 11 seconds to process. Experience tells us that if it took 11 seconds to do the delete in the first place, it should take about 11 seconds or somewhere in that neighborhood to roll it back. So let's go ahead and issue our rollback. And remember, part of this rollback, undoing all of those things, we got to go back to our transaction log, add in a bunch of compensation records, do a bunch of other stuff in there, modify more metadata. So this is just more pounding against the transaction log that it takes for us to be able to complete this. And it's actually taking longer to roll back the transaction than it did to actually do the delete in the first place.
Yeah,
That's
my experience. I would expect it to be like 3 minutes.
Well, we'll see how long it takes. Oh, there we go, 32 seconds. So about 3 times as long for it to roll back. One of the reasons that may be, and I didn't look at the query plan, but I should have. But one of the reasons that might be is that rollback is always single-threaded. So if your query that was modifying things earlier was parallel, your rollback is going to be single-threaded and can take significantly longer, which in this case was about, 3 times as long for us to do that rollback. We'll go ahead and issue another checkpoint. Make sure changes are persisted to disk. Let's take a look at the size of our transaction log. Now, having done that checkpoint, it should be maybe a little less. Okay, so we're back down to 570. So still more than we had before by maybe just 1% or so. But again, we had to do a lot. If I hadn't issued that checkpoint, we would have been taking up a lot of space in the transaction log. So that's probably about as deep level detailed as we're going to get so far in these demos. So I'm not going to run, all of these queries are still in there for every single part of the demo. And then when you get the scripts, you can play around with and run them however you want. In the interest of time, because I see it's already almost 20 past the hour here, I'm going to go ahead and some of the explanatory queries I'm going to skip. I just want to show you the fun stuff. So let's switch back our context back to master. Let me actually make sure that these are in master real quick. Okay. And turn ADR back on. So now I've got ADR on, going to our demo file group. And I'm going to start that delete again. And let's see, first time it ran for 11 seconds. Oh, I forgot to write down the rollback time, which was 32 seconds. All right. So 11 seconds for the delete, 32 seconds for rollback. So now we've got accelerated database recovery turned on. Let's see how long it takes to delete 200,000 rows now. What do you mean invalid data table? Oh, it's because you're in master. Haha. Dragon. Thank you for playing. So 11 seconds the first time, 3 seconds this time. So the delete was significantly faster as well. Why is that? A lot of what's happening here is that those rows aren't actually being deleted or marked as ghost, and the metadata is not being updated behind the scenes. All SQL Server is doing in this case is saying, hey, this row right here, not valid anymore. To you, it doesn't exist. Didn't make any changes on disk. Didn't make any modifications to any other part of that record, just to tag it and say, you know what, hey, the version of this row is invalid, so you're not allowed to display it. Now, if I go and look for an open transaction right now, because remember we did this in an explicit transaction, it doesn't actually show it to me. Because as far as SQL is concerned, that transaction is over. However, tran count will still report an open transaction. In this case, it's actually showing 2 open transactions, which is interesting. So my row count should still be 0 because we just deleted 200,000 rows. Yep. So now, what's in this persistent version store right now? What's in the PVS? Let's take a look. Not a whole lot. We do have some information in there. So we've got about 8K worth of information sitting in the PVS right now. And that's just a note that says, hey, those records, not valid. So if somebody selects against that table right now, they will not be able to see those records. I will issue here, let's see. Make sure I'm in the right place in my script. Okay, I'm going to skip using actually, I probably should take a look at the log space. So checkpoint, how much log have we used? So actually, our log space went down a little bit because we didn't actually require storing all of that additional information in the transaction log, all of those metadata updates, excuse me, all of those delete row records. We don't have to put those in the transaction log because those rows are just marked invalid by the persistent version store. Now, in about 3.5 seconds to delete. How long to recover? How about 5 milliseconds? So exact same operation that we did before, but with accelerated database recovery turned on, recovery is almost instantaneous. And all of those rows are back where they were. Technically, they never left. All we did is tell SQL, you know what, don't display those rows right now.
So that makes, we have 2 questions then.
Sure.
One question is the S-log only used with ADR, or is it a constant feature of 2019?
My understanding is that it is only used with ADR.
Okay.
I am
and
not aware of any other feature that uses the S-log.
Okay. My other question is, does that mean when you're using ADR and while you have that transaction and those other rows have been marked as invalid, does that mean if you were to still use like a DBCC page value, you would still be able to see them though?
Yes, you would still be able to see them if you examine the page itself. It's sort of like a delete where a record gets marked as a ghost.
Okay.
But if you were able to run your DBCC on that page before the ghost cleanup process happens, here's a way that you can actually check this. Hang on a second. I hate making promises and then saying, wait a minute, am I allowed to say this? Let me check one thing real quick because this is kind of a cool idea. I'm glad somebody brought this question up. Let me see. Yay, yes, I can talk about it. Okay. So there is a trace flag called 661, or trace flag 661 actually turns off ghost cleanup. So what you can do is you can turn on trace flag 661, run a whole bunch of deletes against your database, whatever version you want, and then use DBCC page to go and look at those pages. You'll see that the records are still there, but that they're actually marked as ghost records. Once you turn ghost cleanup back on, then all of those records are going to go away. You won't be able to see them using DBCC page at that point. So you either have to get in there really quickly as soon as you've deleted something before ghost cleanup fires, or turn ghost cleanup off. Then you'll still be able to see those records on that page.
Oh, very cool.
So, yeah, it's funny you actually bring that up. I actually was troubleshooting a ghost cleanup issue for a customer recently. So I got to go way deeper into ghost cleanup than I ever thought I would. But, again, when you're processing, millions of transactions every minute, it's, you pay attention to stuff like that. All right, so we just finished that demo. Any other questions before I move on to the recovery demo?
Not seeing anything else in the chat at this point.
Okay, I'll go ahead and go through this. So one thing that I do want to say is that when I'm not sure how you distribute the scripts, by the way. Do I just zip this up and send it to you, Dan, and you send it out to attendees?
If you have a GitHub, and just send me the link. That usually works out well. Or if you've got a repo or something. If not, then yes, you can just zip it up and send it to me.
You know what? I don't think these are up there. I'll send you. You know what? I'll send you the zip for now. But once I do get a repository for this stuff up and running, I'll I'll make sure that that's out there.
Okay, sounds good.
All right, but I actually include 2 versions of this, of these particular demos. So the ones that I'm going to show you are going to be using deletes. The ones that, there are another set in here that actually use updates instead. The main difference between those two is when you run this query right here to look and see what's in the PVS, that's when you're going to start to get an idea of how much space that PVS actually takes up, because it takes up significantly more space for updates than it does for deletes. So if you have a very, very update heavy transaction load, it's going to be more of a cost benefit analysis for you to use ADR than it would be if your workload is mostly insert, delete, insert, delete, insert, delete. I will, because this takes a while to generate, I will leave that to the rest of you to run those scripts on your own. And I want to look real quick at recovery. So we're in master and we're turning ADR off. I don't know why I left this double check query in here, but I did. So let's recreate that demo table. And it's going to be a little bit smaller this time, but it doesn't have to be huge for this particular demo. Let's see how many records I end up with. Oh, I would have sworn I just hit that no count. All right. I'm losing my mind, apparently. No count. Thank you. All right. So I'm going to grab some of my favorite commands right here. Shut down with no wait being one of them. Great for testing. And I'm going to go ahead and run that delete again against my data table. This is with ADR turned off. So we'll see about how long it takes for us to chunk through and delete all those rows. I was going to say it shouldn't be too much. It shouldn't be too long because I'm using smaller pages this time. I think I said 4,000. Yeah, only a 4,000 character column this time. So smaller pages, it's going to run a little bit quicker. So about 5 seconds to do that delete. And then once that delete finishes, we haven't committed the transaction yet, but oh no, boom, SQL Server crashes. So everything got written to disk, everything got persisted. So all of those uncommitted changes got persisted to disk. So when SQL Server comes back up, it's going to have to undo all of that. So we'll close out this window. No, I don't need to save that. We will disconnect here. And then I need to start SQL back up. All right. And I'm going to give it a couple of seconds before I move on to this right here. So I'm going to go ahead and look in my error log. And I'm going to look specifically for messages related to my demo ADR database. So this is going to show me all of the different startup messages that I've got as it's processing that recovery. So let's see if we're there yet. Oh, I got to connect first. Hang on. All right. So here we go. Recovery of database, so on and so forth. Let's see. I'm going to back this up just a little bit.
Still very readable.
Okay, good. Okay, here we are. So recovery completed for demo ADR, about 16 seconds it took for us to recover that database. Again, that was just for one delete transaction. Had this been, you know, a highly volatile database, lots of simultaneous transactions, you can imagine how long that would actually take. And let's see, I think if let me actually grab this real quick. And I will show this in a new note here. So this is the type of message where you would be able to tell what phase your recovery is in right here. So it's going to say phase 2 of 3. And it'll give you a usually pretty wild estimate of how long it's actually going to take to recover the database. I don't ever go by these. I really don't, because it's doing its best. It's like that, you know, progress bar that says, you know, 50% complete, 75% complete, 80% complete, 60% complete, 70% complete. Yeah, so don't go by these times. But you do want to see what phase of recovery it's in if this is something that you're troubleshooting, if you're actually troubleshooting a recovery issue. You want to know how long it roughly spent in that phase.
Yeah, the one thing is that if it grossly overestimates, that's what you tell your manager when he says, how long is it going to take for this to come back up? That's the answer.
There you go. Yep.
We did have another question, if I can jump it in real quick.
Please do.
If you have a database that has large batches, inserts, updates, like a data warehouse, when PVS cleanup runs, how resource intensive is it? Could the cleanup process cause performance issues when it runs?
Not that I am aware of, because the operations that it is running are going to be separate from where most of your modifications are happening. Yeah, the records that it's going to be removing, I mean, okay, so from a concurrency standpoint, from a, locking, blocking, metadata changes, that type of stuff, it will not make a huge difference. Depending on how much there is to clean up at the time, you may see a little bit of IO performance degradation. I can't off the top of my head say how much. I've heard anywhere up to, if I'm remembering that conversation correctly, trying to remember what we were talking about at that point. Could be potentially up to 2 to 3%. But again, that's one of those things that you're going to need to test in, excuse me, in your particular environment. Another thing that can actually affect that is frequency of log backups as well. So again, the more frequently you're backing things up, the more frequently you're truncating your transaction log, more frequently you're saying, hey, this is the recovery point for my database, the more frequently that cleanup will run, and the lighter those cleanups will be. So that's something else to take into account as well.
Got it. That catches us up.
That question. Okay,
yep.
Cool. All right. So here's what our normal recovery looks like. So we go through our phases. We write the checkpoint. We say, okay, we were done. 16 seconds it took us to recover this database. So now I'm going to do roughly the same thing again. Let's just verify all my rows made it back. 202,950. Very good. Now we'll turn accelerated database recovery on. And I'm going to set up my gremlin again here so I can crash my database. All right, and run my delete transaction. Go. And it was about 5 seconds the first time, 2 seconds this time, because again, there's a lot of those metadata changes that are happening behind the scenes when we mark records as invalid and pages get removed, all going to the S log, which is in memory. And there's a lot of stuff that doesn't have to happen because we've got that row versioning turned on at the database level. So that's done. We'll write our checkpoint and bring SQL Server down. And we go. All right. So we'll close this. Oh, I'm not going to switch. I'm going to disconnect. All right, and where's my PowerShell? There it is. Start that back up. And we'll give it a second or so and say, what's my recovery like this time? So we get a whole different set of messages, or I shouldn't say a whole different set, but we get a much more limited set of messages. The same type of stuff, sort of, had to happen behind the scenes, but because we were replaying from that copy of the S-log, which was very light, one thing that I did forget to mention is that the S-log itself, when it's being actively written to, is in memory, but like all in-memory tables where there is some sort of durability requirement, it is asynchronously being written back to disk. Not a whole lot of information, very lightweight, not something that I would consider a performance consideration. But we did our usual database startup. We got our parallel redo. We rolled back that one transaction, but you notice we don't have any other recovery messages in there. just to say that, hey, we wrote our checkpoint and we shut down parallel redo. That's it. We don't even get the message that says recovery was complete for this database. So how long did it actually take? About 340 milliseconds, rather than the 16 seconds that it took the first time. So that brings me to the end of the demos that I have for right now. Like I said, I'll go ahead and I'll get those scripts bottled up and sent over to you, Dan. You can post those for other people to play with.
Mm-hmm.
If you do run into, if you do run into any issues with the demo scripts, or you've got questions about what's on the slides, or something that you think could use more explanation, or really anything at all to do with the presentations, please do feel free to reach out and contact me. I'll have my I don't remember if I put a bio slide in here or not. Let's take a look. No, I did not. Bad presenter. No speaker gift for you. Okay.
You have your email, I think, at the top of your scripts, though.
Do I have it in there? Oh man, I hope I do. Yep, there it is. Okay, so yeah, it's just david.maxwell@microsoft.com, so you can feel free to reach out to me with any questions that you have, or if you find something in the scripts that says, hey, you might want to try doing it this way. That's the kind of feedback that I love. When somebody sees something in my scripts and says, hey, it might make more sense if you did it this way. Awesome. You just helped make my presentation better, which I thoroughly appreciate, so please do that. So that's all I've got for right now. ADR is one of those features where there's a lot of places where it really, really helps out, especially from a performance standpoint, and most definitely from a recovery standpoint. There are one or two caveats, things to keep in mind when you implement it, just like any other feature in SQL Server. But yeah, I think it's pretty cool. I think it's pretty cool. Do we have any other questions or any other discussion?
Not seeing any other questions in the chat. Oh, go ahead.
Okay.
I was going to say hello. I was going to ask this one, with the mic. Or it's not so much actually as someone who was in a previous life was an Oracle DBA. Now, as a SQL Server DBA, I've been waiting for this for years. This is wonderful, to be able to do this. One of the few things Oracle could do that SQL couldn't, and now SQL can too. But one feature that would be a nice to have to maybe put in the people's ears, something that Oracle does with this that SQL Server doesn't. There's a thing that Oracle does called flashback, and what that does is if you keep this the persisted version store is there for a while, even though things have been committed, the data as it was in the past is in there, and you can use flashback to tell it to flash back to 6 hours ago or something, and then you can select from the tables and it'll show you the data as it was at that point in time.
Okay.
So if somebody has deleted data or changed data, you can go back and see what it was. That'd be a really cool thing for them to use this for.
Are you familiar with temporal tables in SQL Server?
A little bit, yeah, like used with databases or data warehouses and stuff.
Depending on the particular use case, that might actually solve that problem for you. So the temporal table functionality, because you can do a you can write a select statement, select data from this table, whatever it is, at system time, and then provide it a date time. And it'll show you this is what it looked like at that time. I'm not sure if that's the same as like the flashback type thing that Oracle does, but
yeah, except the difference that the flashback works on any table, regardless of its type or anything like that.
So that's a database wide enabled feature.
Right. So if you have some user that deleted data and you're like, oh my gosh, what was this before? You can flashback, you can select the data from that table into some temporary table and then go back and, reverse what they did.
Okay.
Interesting. And it's just a good use for something like this. You couldn't do it before.
Sure.
But
yeah, very cool. I don't know if there's a user voice guys, I know there's a couple other people have mentioned that feature to me before. Wish they had seen something like that in SQL Server. I don't know if there's a user voice item out there for that right now or not. There probably is, but let me see if I can look it up. And if I can find a link for it, I'll provide that to Dan as well. He can send it out to everybody, and we can all vote on that feature and say, hey, product group, this is something people want. You should probably do this.
Absolutely.
Awesome.
Yeah, The feature I'm waiting for at this point, though, is the being able to get object level restoration from BAK files. That's what I'm
I know a
waiting.
lot of people that want that one.
Yeah, and again, I think Oracle's had that for a while. So
Yeah,
You can do that. You just restore the database.
yeah.
Oh my goodness.
Well,
Yeah.
once upon a time, way back in the older versions of SQL Server, you could do it, but it went away.
I'm going to go ahead and end the recording right here, and we can keep chatting there, asking other questions, but this way we'll have the recording done.
Yeah, I've got like another 15 minutes before I have to do anything else. So if anybody wants to chat more about ADR or any other SQL Server related